This video is going to be slightly different for 8.2 because I am still going to use the same north and south technique that I've been doing in class. The only issue with it is I'm going to be recording at the same time. And so, if you are watching this video at home, I'm going to recommend that when I tell the class to work with their partner, I'm going to suggest that you fast forward or try it at home, pause the video, and then just fast forward until you see a hand on the screen. The hand on the screen will represent when I'm going to start talking again. Okay? So here we go. What we're going to do in 8.2 that's different is we're going to start introducing quadrant 1 of the unit circle, which is by far the most complicated thing that you've done in mathematics up until this point. Up until this point, probably the most complicated thing that you've learned is SOHCAHTOA. You have now learned how to handle those ratios with an angle and two sides of a right triangle. This will surpass that because it uses a little SOHCAHTOA, and it also uses the 30, 60, 90 and the 45, 45, 90 degree triangles. And so you really need to be on your game, and let's just pay attention and go with it. So if you do not know those two sections, I'm going to recommend that you go back to the 7.2 and watch the whole video again if you need to. But most of you will be able to figure out where I'm going with this as we do it. Okay? So this is number 1. It says label the sides in terms of S. And so I think most of you would know how to do this. Across from the 30 was S. Across from the 90, what would that be? Say that side out loud. 2S. I agree. I'm going to write that right there. And across from the 60 was something else. What was it supposed to be? Say it out loud. Thank you. So you're going to do that for number 1. And you're going to do the same thing for number 2. The problem with number 2 is that it's a 45, 45, 90. So let's see if you remember. Across from one 45 is S. Across from the other 45 is S. And across from the 90 is S square root 2. That's review. That's what we learned in 7.2. Now what we're going to do is we're going to use these two examples to be able to answer the questions, the SOHCAHTOA questions. So every problem that you have on worksheet 2, they're going to say, what's the cosine of this? And so what you're supposed to do, let me shrink this down just a little bit. When it says cosine of 45, you go to the 45, 45, 90 degree triangle and you highlight this angle, just like you did before. So if I highlighted 45 degrees and I went like that, that's 45. You could have chosen angle B as well, doesn't matter. And what you're going to do is, since cosine is ka, A over H, you'll label O, H, and A just like you did before. O, H, and A for SOHCAHTOA. And knowing that cosine, ka, is the A over H, you'll then go and figure out A is which letter, and you'll look at the letter and you see that it's S over the H. H was which letter? S root 2. And you now have S divided by S root 2. Let me just zoom in on that real quick. Well, this reduces. S goes into S one time. Now what you have is that the cosine of 45 is 1 over root 2. The only problem with this is it's not rationalized. You cannot have a square root in the denominator, so we'll rationalize this by multiplying by the number 1. Root 2 divided by root 2 is 1. 1 times anything is itself. We're using the multiplicative identity. And the reason why I chose root 2 over root 2 is so that there's a pair of 2's. Now you have a pair of 2's. They're both inside the radical. They radical. The 2 can pop out. This makes root 2 over 2. So what is the cosine of 45 degrees? It's root 2 over root 2 over 2. Now the crazy thing about that is If you had a calculator and you have one of the Casio calculators and you were to type in cosine of 45 degrees, your calculator would tell you it's root 2 over 2 because it always reduces to the same ratios. They are similar triangles. They are all proportional and they all have this proportion to them, no matter what happens. Now notice I'm showing you that the calculator knows what the ratio is. And we did not use the calculator. We used a triangle to answer this question. Every problem that you have on that first worksheet can be done with a triangle and without a calculator, using these special ones. Our goal is that we will eventually be able to do everything without a calculator and we'll be able to do it from memory. That's our goal. That will happen hopefully by the time we are on section 4. I hope that happens. Here we go. Next one, number 7. Sine of 60 degrees. Sine of 60 degrees. We're not using this triangle anymore. We're using this triangle. 60 degrees is this angle. You highlight the 60-degree angle. You're going to label each of these from that angle. Which one's opposite? You put the O right there. Which one's the hypotenuse? You put the H right there. Which one's the adjacent? You put it right there. And you're going to use that to answer what is the sine of 60 degrees. So if you know what you're doing, you're going to do something like an O and an H. The O is which side length that is in terms of S. What is O? Say it out loud. Perfect. What is H? Say it out loud. So now what we have is that the sine of 60 degrees is S root 3 divided by 2S. Well, that simplifies because S divided by S, S goes into S one time. 1 times root 3 is root 3. 2 times 1 is 2. The sine of 60 degrees will always reduce to root 3 over 2 every single time. If you understood what I just did, then you should be able to do the tangent of 60 degrees. With your partner, tangent of 60 degrees using the triangle, do the problem, check your answers, and if you're at home, when you see the hand, that means that we're coming back. Discuss with your partner. Coming back to you. How many, okay, what did you get for your answer? Say it out loud. Root 3. Is there anybody who did not get root 3? Please raise your hand. 0 hands are raised in this class. Root 3 is correct. I'm just going to put a box around it. If you were doing this TOA and at home and you didn't know, the O over the A would be S root 3 over S, and the S is reduced. And there's no reason to put root 3 divided by 1. Anything divided by 1 is itself. So just write root 3. It's the most simplified way to write it. Okay? The last thing that I have added to your notes is number 3. And number 3 says, what's the sine of theta, what's the cosine of theta, and what's the tangent of theta? Now this is a general triangle that's going to lead us to our unit circle. We don't know how many degrees this angle is, but I bet you if this was the horizontal distance is x and the vertical distance is y, and this diagonal distance, if we call that the radius or r, we should be able to figure out what the sine of theta is, the cosine of theta, and the tangent of theta is. If you know how to do that, go ahead and write those down in your notes. What is the sine of theta, the cosine of theta, and the tangent of theta? And discuss with your partner, or if you don't know, ask your partner how to do it. Go.
Oh, for this, I already have it written down right here. But you don't know. No, I know. So for sine, I got y over r, cosine, I got x over r, and then tangent, I got y over x.
I am hoping that you got that the cosine of theta was x over r, that the sine of theta was y over r, and that the tangent of theta was y over x. If that's what you got, please raise your hand. Wonderful, that's everybody. Now, the whole reason we do number 3 is because now for any angle, it doesn't matter if it's in quadrant 1 or quadrant 2 or quadrant 3 or quadrant 4, if we know what the reference angle is, there's always a horizontal component, a vertical component, and a radius. And for whichever angle it is, it doesn't matter which one is which, the cosine will always have the x in the formula, the sine will always have the y in the formula, and the tangent has a y and an x, which means a sine and a cosine in the formula. As a matter of fact, if you want to know, the tangent is equivalent to the sine divided by the cosine. There is a proof of this in your notes. I'll kind of just lightly talk about it. If you know that the cosine of theta is x over r, and you multiply this side by r and this side by r, you would get this equation, x is equal to r cosine theta. If you knew that the sine of theta is y over r, which you just told me it was, and multiplied by r, y would equal r sine of theta. So I know what y is equal to, I know what x is equal to, and since the tangent is y over x, you can now substitute that in and that in for y and x, and the r divided by r means that the tangent of theta has to be the same thing as the sine divided by the cosine, as long as those angles are the same. That's going to help us later on as we're doing problems. Knowing that the tangent is the same thing as the sine divided by the cosine is going to help. The other thing that's going to help when we get to the unit circle is that we're going to start with a radius of 1. Which means if I'm thinking about the graph paper that's on Mr. Promo's board, he has graph paper on his board, and there's all these little lines like this, and all these lines like this, and then lines like this. If we're talking about a radius of 1, we're talking about like the innermost, smallest little circle. That's what we're really talking about. The radius is 1. This means that every ratio, if we go to the unit circle, if it has a radius of 1, we'll be able to figure out everything else based off of this particular size of radius. Don't let that freak you out. Let me erase. Don't need that. If the radius is 1, then in the formula you just told me, your cosine of theta, if the radius is 1, is always going to be your x coordinate. That's important. Your cosine is always going to be your x coordinate, your horizontal distance. Your sine, if the radius is 1, sine of theta would equal y divided by 1. Guess what? The sine of theta will always be equal to your y, otherwise known as your vertical distance. Your cosine is your x coordinate, your sine is your y coordinate. And tangent is sine divided by cosine, which brings us to this. You should have something like this in your notes. This is the top right corner of your unit circle. What we're going to do is we're going to fill it in together, and I'm going to explain to you what goes where and why it goes there. And some of you might get confused at this point, but let's just see if you can keep up. First and foremost, this, if I go, the smallest angle I can have is 0 degrees, meaning I don't have an angle at all. It's 0 degrees. It's where we begin. The next one that goes up, I am going to a pre-picked out angle. That angle is 30 degrees. I am not going to use 15. I'm not going to use 5. I'm not going to use 10. I'm not going to use anything else. I'm going to 30 for a very specific reason. I'll explain in a second. Then I go to 45 for a specific reason. I go to 60. And then over here, I go to 90 degrees as well. These 5 angles are the only angles we're going to use. Each of these 5 angles has a very specific x and y coordinate based off of the triangles that you just worked out. For example, if I'm talking about 30 degrees, I'm going to draw you something in blue. Draw, blue. I'm going to draw this line straight down here and then draw this over here. I'm supposed to be making straight lines. That was really ugly. So let me see if I can get a really straight line here. Here, I have a line tool I could use. Oh yeah, that's so much better. And then there. Perfect. Oh, I don't know. I want to move that down a little bit. That looks better. So now that we have that, and I go back to my drawing tool, this angle, meaning this angle, we chose a pre-picked out angle, 30 degrees. This creates the same angle, the same triangle that you were working on above. You told me across from here was S, across from there was 2S, and then here was S root 3. You remember that? So if I'm trying to figure out what the x coordinate and the y coordinate is, we can do the exact same thing for this angle. Meaning, if I want to know what the cosine of 30 degrees is, cosine of 30 degrees is the A over H. All I do is this over that, and I know what it reduces to. It always reduces to the same thing. Root 3 over 2, and that's my x coordinate for my unit circle. Cosine deals with your x. If you want to know what your y coordinate is, which trig function do you think I'm going to use? Say it out loud. Exactly. You would do sine 30 degrees, and you can go opposite over hypotenuse, but it's always going to reduce to the same thing. What's it going to reduce to? No. Try again. No. Try again. S divided by S goes in 1 over 2. The sine of 30 degrees is 1/2. That's your y coordinate. Every single time. There's no reason to rationalize. There's no reason to do anything else. And it's all based off of the 30, 60, 90 degree triangle. That's why we choose this angle 30 degrees, because all the ratios are going to be the same. It's something that we've done before. And if that's what we did for the 30, then guess what? We have a 45, 45, 90. We have an x coordinate and a y coordinate. Now I did this one in blue. Let me switch to a different color so you can see it. Green. And let me get the straight. Hopefully I can get that down there, and hopefully I can do one more. Now I have a green triangle. It's 45 degrees, so from here to here is 45 degrees. And now I have S root 2. If I'm thinking about the x-coordinate, the cosine of 45 degrees. We've already answered that question. It's right there. I already know what it's going to reduce to. But before I do that, let's look at this. It's the same thing as the adjacent over the hypotenuse. The cosine of 45 degrees, the x-coordinate is always going to be root 2 over 2. Now, based off of that, the sine of 45 degrees is the opposite over the hypotenuse. Do you know what the y-coordinate is going to be? If you know, say it out loud. Ooh, we don't know. Okay. The sine of 45 degrees is what? Okay, well, let's use SOHCAHTOA is what? Over what? O over H. The O is the S. The H is the S root 2. S over S root 2. Got to rationalize it. What will it be? It'll be, it's the same thing as the cosine for 45 degrees. So because we did it that way for the 30 and the 45, the only thing that's different about the 60 is that when you draw this thing down, we have a 60-degree angle. We have a 30 up there. You need to figure out what your cosine is and what your sine is. With your partner, north person, you have to figure out the cosine. South person, you figure out the sine of 60 degrees. I want to know what goes there and what goes there. And then discuss how you got your answer with each other. Say it again.
Finding the cosine and I'm finding the sine.
The cosine of the sine?
Why do you find those?
We're finding the x-coordinate and the y-coordinate. What is it? We're comparing the two sides of a triangle. We're comparing the A and the H. It's always going to be the same ratio.
Tangent 1 equals. That's why.
But it applies to radius 2 and
So if
radius.
there's a radius of 2, you just multiply each side by 2.
Then it would be
2 root 2 over 2.
10 times 3 or 20 times 3.
Alright,
We're going to talk about that. Haven't got that.
tangent 90 degrees is much more.
I love it. It's awesome.
Is it because then the hypotenuse is tangent?
But you can't make a triangle.
Yeah, you can have a triangle that has 2 sides. I think that does make sense. Oh, so what do you want us to put there?
Coming back. How many of you figured out the cosine? Raise your hand if you figured out you have an answer for cosine. Okay, that's not everybody. So, do you need more time or you guys got stuck? That's what I need to know. It's what?
1/2.
I agree. What's the sine? There you go. Everything we do on the unit circle is 100% based off of the 30, 60, 90-degree triangle, the 45, 45, 90-degree triangle, and a radius of, how much did we say the radius was?
1.
Now think about that. If this is a radius of 1, and I said that this is the coordinate, I'm talking about this point right here. Let me put a big red dot right there, and I think about, remember how I did this and I said it's a radius of 1, and we're now at this location right there. What's your x-coordinate and what's your y-coordinate? What's your cosine and what's your sine? 1, 0. Has to be. You went 1 to the right in the x direction. You went 0 up in the y direction. Yes, sir.
So is that the one for 90 is 0, 1?
What do you think that the 90 is going to be? Do you agree with Drew?
I think so.
Let's say this. What is the cosine going to be, or what is the x-coordinate going to be? Say it out loud. What is the y-coordinate, also known as the sine? What is the sine of 90 degrees going to be? Say it out loud. This is the first quadrant of the unit circle. By the time we get to section 3 in your notes, we're going to do all 4 quadrants, and it's all based off of this information right here. Aaron, what other line are we? This line right here and this line?
Yeah.
There's another way to measure the angle. It's called radians. We are not measuring that angle in radians yet. We are just doing degrees for now. Later on, you're going to learn how to measure this in a different way called radians. Very observant. Don't worry about that yet. Which brings you to the chart. The chart is something that I added to the notes for next year. And the chart is in your worksheet. So if you want to jump to your worksheet, feel free to do so. You have 2 choices on the chart. You can either use the triangles like you did on number 1 and 2. Remember how we had those triangles and we answered these questions based off of the triangles. Cosine of 45 was root 2 over 2. That's the same thing for the chart. I just want to show you a different way. If this says the cosine of 45 is root 2 over 2, let me show you how to use the unit circle. Here's my unit circle. Here's 45 degrees. What's your cosine, otherwise known as your x-coordinate? What is it? Is that the same answers as we got for number 5? Yeah. So that's what you write in this box. Now let me check to see if you understand. What is the sine of 45 degrees? If you said root 2 over 2, you get it. You understand. If I said, what's the cosine of 0 degrees? I'm asking, what's the x-coordinate of this angle? You can look over here, or you can use a triangle if you want to. I heard 2 different answers. The cosine of 0 degrees. The cosine of 0, cosine is your x-coordinate. What's your x-coordinate? The cosine of 0 degrees is the x-coordinate. And that's the y-coordinate. That's your angles measurement. X-coordinate. That's a comma. Yes, that's a comma. X, Y, and so on. Hey, that's why we're clarifying. Now, earlier, I talked to you about tangent. I said that the tangent was the same thing as the sine divided by the cosine. So if I ask you to find the sine divided by the cosine of, let's say, 0 degrees, the sine divided by cosine, otherwise known as the tangent. Zero divided by 1 is 0. You can do the same thing for 30 degrees. The sine of 30 degrees is 1 over 2. I'm going to do the 30 degree angle. The sine is 1 over 2. The cosine is root 3 over 2. If you're doing sine divided by cosine, some of you are going to get this complicated fraction and you may not know what to do. But just if you see the same denominator, you can reduce those because you're multiply the top by 2 and the bottom by 2 would get rid of those. Or you can just say, instead of dividing by root 3 over 2, you can multiply by the reciprocal. It's the same thing. which makes 1 over root 3. That is not rationalized. Multiply by root 3 over root 3. And then you get root 3 over 3. So there is some rationalizing to the tangent, by the way. So the last thing that I'm going to show you, I'll let you fill in the rest of the chart on your own. The last two examples are what do we do about the ones that are on the ends? Well, you can't really make a triangle out of the ones that are on the end. So it's just easier to remember that when you're at 0 degrees, you're at 1, 0, and when you're at 90 degrees, you're at 0, 1. That way you can answer those questions. Yes, sir?
So is the tangent of 90 is undefined because 1 divided by 0 is undefined?
That is correct. As a matter of fact, that's why number 19, I have it chosen. It is undefined. 90 degrees would be 1 divided by 0. Division by 0 does not exist. Because it does not exist, we're going to write that it is undefined. 0 dividing by 0 would be like cutting something up into nothing-sized pieces. It's a weird concept. Think about trying to cut something up that's smaller and smaller and smaller. You would get an infinite result. Think about that. We'll define that more fully later. The cosine of 90 is the one straight up and down. What is the cosine of 90? 0 is okay. So we're going to end our notes right there.